So in the previous section, we have discussed about ionization energy and we have seen some questions, what generally IB asks. I'm going to do one more practice on the questions related to the topic of ionization, and then we'll see the trend of ionization energy in period and in group. So before we are discussing trend of ionization energy in group and period. Okay, so before, let's continue with one question which I have asked in the previous. So let's say I'm going to create a table. The table shows successive ionization energy for X element. Okay, we don't know the name of the element, we have to find out in, and this element is present in period number 2. So the table is, let me write a table. So this is ionization energy. So this is 1, 2, 3, 4, 5, 6, 7, and 8, and ionization number. Okay, and this is ionization energy, which is given in kilojoule mole inverse, right? So ionization number, first is 1513, this is 3300, 5300, 7400, 1089, 13327. For this one it is 71337, and for the 8th one is 84080. Right? So you have to identify. Question is identify X. This is the question. So as we are seeing here, this is, here you have a difference of 1500 something, nearby 2000 and 3000. So the largest jump, if I can see, is between ionization energy 6 to 7. Can you see? This is 13,000 and 71,000. This is a big jump, right? Means the 7th electron is being removed. That is why this much energy is being used, right? Therefore X element, so the element present here belongs to group number 16. So I can say that the largest jump in ionization energies is between ionization energy 6 to ionization energy 7. And this means that the 7th electron is being removed, right? And from where we are removing from an energy level. Close to the nucleus. Fine. So therefore X element belongs to group 16, and if element is in group 16 and in period 2 as per the question, it must be oxygen. This is the answer, right? So ionization energy shows periodicity. They follow a kind of trend, right? Let's talk about that. We will discuss about periodicity. When we say periodicity, the meaning is there's something, a kind of trend is being followed, right? So here also ionization energy shows periodicity, right? Periodicity means a trend ac- across a period of periodic table. Fine. So as could be expected from the electronic configuration, group 1 metals have, we have seen relatively low ionization energy, whereas noble gas have higher actually. So if you will see the periodic table is something like this, right? This is group 1, this is group 18, 17, 16, right? Something like this. So like this. So generally this side you will get non-metals generally, right? These are the area of a non-metal, and till here actually this whole thing majorly the more metallic character we will find here in the first group, so they are metallic, right? So now the question is, if ionization and energy is following a trend, what are the factor controls these things? Let's discuss about that. So we can say that the size of the first ionization energy is affected by four factors. Now, what are the four factors? Number one, size of nuclear charge. Second factor, distance of outer electron from the nucleus. Third is shielding effect. Shielding effect of inner electrons. We'll discuss about shielding effect in more detail now. And the last is spin pair repulsion. So, the ionization energy increases across period, and it always, like, as you will go down, let's say take an example, the first group, hydrogen, lithium, sodium, right? Hydrogen, then this side we have helium, 18th group, lithium, beryllium, boron, carbon, nitrogen, oxygen, neon, then sodium, then potassium, something like this. So hydrogen is 1, lithium is 2 comma 1, sodium is 281, potassium is 2881, right? So what you are seeing here, to we can see here that if I'm going to take out one electron from this particular element and from this particular element, you will find this is easier than this, because you have to take out electron from the fourth cell, so you have to invest less energy because effective nuclear charge is less, size is more, right? So size, more size, less ionization energy you have to give to extract the electrons, right? So what a general conclusion we can draw? We can draw that first ionization energy increases across a period and decreases down a group. So as we are going like this in the periodic table, ionization energy increases. As we are going like this in the group, you will find that ionization energy decreases, right? So, and if you will see the trend, let me show you the trend. Let me make a graph. If I am making a graph like this, here you have atomic number, Z. Here you have first ionization energy, which is given in kilojoule mole inverse, right? Let's say starts with 0 atomic. Let's see the ionization energy trend. Of hydrogen to sodium. Okay, so here you have, in between I'm putting 5, then 10, right? Energies are, will give 500, 1000, 1500, 2000, 2500. So you will find the trend is something like this. Hydrogen, we have seen it is nearby in between 1000 to 1500, so we'll put one dot here. Helium is nearby 2500 something. Then lithium is down, right? So lithium is somewhere here. Then we have beryllium, somewhere here. Then beryllium, then boron is here, then carbon, nitrogen, then again slight dip in oxygen, then fluorine, then neon, and sodium is less. So if I'm going to join the dots, it's something like this. So this is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. So what we are seeing here, that ionization energy is actually decreasing when we are going from left to right in a group, right? And so let's individually let's discuss about uh, ionization energy across period. Then we'll talk about ionization energy across a group. Fine. So what we have seen that the ionization energy across period generally increases due to the following factor, right? So generally, when the ionization energy generally across a period let me rephrase this statement. I can say ionization energy across a period generally increases, right? Why? Because of the nuclear charge, right? So I can say due to across a period the nuclear charge increases, right? Then we have seen radius, and as the nuclear charge increases, that means it causes atomic radius to decrease, right? And outer shell pull closer. So outer shell pulled closer to the nucleus, and the distance between the nucleus and the shell decreases. Distance between nucleus and electron shell decreases. And then what will happen? The shielding by inert electron reasonably constant. So shielding effect remains reasonably constant. And when they are constant, it becomes harder for an electron to take it out, right? So we can say it becomes harder to remove an electron, right? So as you move across the period, more energy needed, so ionization energy increases, right? So as we go up, so I can say as you move across period, more energy is needed, right? So ionization energy increases. Now you'll also find that there's a dip in the trend. Now what is a dip? Let's talk about that. Dips in the trend. Where is the dip? So there are slightly decrease in ionization energy between beryllium and boron. As the fifth electron is boron is in 2p subshell, which is further away from the nucleus of the 2s shell of beryllium, right? So let me make a statement for this. So what I was saying, that there is a slight decrease in first ionization between beryllium and boron. Why? As the fifth electron in boron is in 2p subshell, right, which is further away from the nucleus than 2s subshell of beryllium. So you will find in case of beryllium, the first ionization energy is 900 kilojoule mole inverse, and its electronic configuration is 1s2, 2s2. And in case of boron, the first ionization energy is, let's say, 800 kilojoule mole inverse. And what the configuration? 1s2, 2s2, 2p1. So in a similar way, you will get a difference between nitrogen and oxygen. So nitrogen is, its first ionization energy is 1400 kilojoule mole inverse, right? And for oxygen is first ionization energy is 1310 kilojoule mole inverse. And if you will see the electronic configuration, this is 1s2, 2s2, 2p1, 2p3 actually. So when I'm saying 2p3, in this case this is 1s2, 2s2, 2p4. So if I'm going to show the orbital arrangement of the p subshell, find there is a 1 electron here, 1 electron here, 1 electron here, and in this case 1, 2, 3, 4, right? So there is a slight decrease in the first ionization energy here. This is difference because of spin pair repulsion. Fine. So here the difference we are getting, this difference, let me circle it. This difference is coming because of spin pair. So wherever you will find such differences in the same subcells, this is because of the spin pair. So in oxygen there are 2 electrons in px, right? So if I am going to say px, py, pz, px, py, pz, so let's compare the px part of both here, this part. So what we are seeing here, you have 1 electron, here you have 2 electron, right? So in oxygen there is a 2 electron in px orbital, so the repulsion between those electrons make it slightly easier for one of the electron to be removed. That's why this difference you are finding. Let's talk about, let me go up, let's talk about what is happening in the group, or I mean better we can say, let's see the from one period to the next, from one period to the next. So here you will find that there is a larger decrease in the ionization energy. Large decrease in ionization energy between the last element in one period and the first element in the next period. So now why this is happening, why it is decreasing? Because of two reasons. First, why this is happening, let me write. Because uh, okay, so first reason is there is increased distance between the nucleus and outer electron shell, because you have added a new shell. There is also increase in shielding effect by inner electron because of adding a new shell, right? So there are two factors which so these two are actually decreasing the ionization energy. So there's a large decrease. So increase in shielding effect of the inner electrons because of the added shell, and here also outer electron as you have added a new shell. So that's why this difference you are finding. Topic is done, and soon we are going to discuss the questions, and I will expect students to text me if there is any question. I will be happy to answer. Thank you.